I'm going to be talking about Ecomaps, mapping natural capital, and the slightly longer, less sexy title is modelling approaches using site survey for national scale mapping. So I'm talking on behalf of mainly the land use group, but there are other people outside of the land use group who have also been involved in some of this work. So I thought I'd start by trying to talk about why map natural capital and trying to define what natural capital is. So because, I don't know, some of you may be less familiar with the term than we've become. So it's pretty much everything that's not man-made. So it's the elements of nature that produce value to people, both living and non-living, but not non-living people, non-living parts of nature. And it essentially underpins all other types of capital. You may say, well, what are those? And they're social capital, cultural capital, economic capital, basically people capital surrounding our social structures, etc. And if I'd been doing the talk a few years ago, we may have said mapping ecosystem services. But I think we've learned quite a lot in those few years to separate out natural capital from ecosystem services. And I was trying to think of a good way of showing you this. And these little pictures are supposed to show it. So the one on the left shows a person walking in the mountains and drinking directly out of a stream. So that there is no, that's just the natural elements producing the water. There's no structures between the person and the water. They're getting it straight out of the stream. In the other case, there's a young boy drinking out of a tap. And in order for that water to be a service to him, for him to get that water, a whole load of social capital and cultural and economic capital have gone into getting that tap there, deciding there should be a tap there in the first place, having a business that supplies the water, etc., etc. So that's at the end of the ecosystem service delivery, in which a lot of social and cultural capital have been involved. And the mountain stream is supposed to represent the other end of that, where it comes direct from the natural system. So why would you bother to map this? Well, I think everybody likes a map, and maps provide a way of visualising spatial measures. So I could give you bar graphs or scatter graphs, and you can look at them and see what the results were. But actually understanding how they relate to places, it's really important to be able to look at a map and see your data. So maps are also particularly useful for land managers. That's a very broad definition, to prioritise their actions. So they say, well, it looks like the services look, or the natural capital looks like this in that area, therefore I'd like to make that more important for those elements of natural capital, so therefore I'll do this, that or the other. I put a warning sign on because though maps are lovely and we all like to have a good map, we have to be wary of exactly what they tell us, and not to. They're like any other tool. They are a tool, and they're not necessarily to be believed at every level. So they provide something useful, but they're not the absolute gospel truth in every case. Who's interested in maps? I've put land managers, but that can cover a broad area. So at the local level, you would have a farmer or a forester who's actually affecting directly what's happening in an area. At the regional level, it might be the council who are making planning decisions about where you can or can't place a building, or potentially offsetting decisions in the future. And at national level, that would be politicians, civil service, DEFRA, deciding on where to prioritise actions in various policies. Okay, so it won't be any surprise to you that I'm going to talk about countryside survey and mapping, and that's because countryside survey is an excellent data set for mapping. So what are the data? What do you need if you want to produce a good map? And ideally you'd have high quality data from absolutely everywhere, but that's quite difficult. We do have the land cover map, which has high quality data interpreted in the same way from satellite imagery for everywhere. That's one form of data. And another way is to use a representative sample of sites. So rather than looking really closely at everything everywhere, you can look really closely at a representative sample of sites, and then you can extrapolate what you find from there to everywhere. And that's the principle underlying Countryside Survey. And Countryside Survey is a survey which is based on a stratification of Great Britain by something called land class. And so a large number of variables, 40 odd, were put into a model which then determined which areas of the UK were most similar to each other. And you can see the map there of GB land classes. And they represent areas which are similar in terms of topography or climate or underlying soil types. And then within that stratification of land classes, CES carries out goes and looks at a number of 1 kilometre squares. So the number represents both the presence of the land class and how big it is. So you'd have 6 squares in one land class if it was small, and 8 in a bigger one. And so we go and look at those squares in great detail. So this then allows us, so when we want to actually provide maps of natural capital, then we can use land cover map. So we can say that if you want to have a measure of natural capital which is associated with a particular habitat type, like woodland, you could use land cover map to make a map of that particular measure of natural capital. Or you could use the CS land classes. So if you knew that land classes had a measure, a particular measure of capital, then you could just do a map which extrapolated across to all the land classes. And I'm going to show you some examples of all of these. So using a model-based approach, you could use either the underlying habitat types from land cover map, or you could use land class, or you could use both, or you could use neither and use a whole range of different variables. And you can use other Countryside Survey measures to make predictions of natural capital. And using a model, you're able to create some uncertainties associated with that model. Right, so a quick mention of the integrated assessment. So this was a piece of work post-Countryside Survey where we worked very closely with a policy topic group from across GB to look at how Countryside Survey can be used to provide national data on natural capital, which essentially were indicators of ecosystem service. So back then we did sort of talk about ecosystem services, but we recognised that what we were producing was essentially the underpinning natural capital. So the kind of measures within Countryside Survey that you can use are the plot-based measures, and we did more than 16,000 plots in Countryside Survey 2007, and we called plant species presence and abundance. And one of the things we've looked at, and I'm going to show here, is nectar provide plants, and they obviously deliver a pollination service. We also do soil cores in our X plots, of which we have 5 in each CS square, and we measure topsoil carbon using loss on ignition in those soil cores, and that gives us a measure of sequestered carbon, which is important for climate regulation. For freshwater invertebrates in headwater streams, that's another of our measures. I'm not going to show that example, it's quite complex, but this is some work that Sheila Green and I have been doing, building on original work by Mike Dunbar, looking at the CS squares. And that gives us a measure of water quality and of clean water provision, which we can try to scale up and look at the whole country scale. And finally, the habitat type and extent. So that can give us an indicator of landscape quality. We all like looking at particular elements of landscapes, and they therefore are a cultural service provision. So they're giving us something in terms of enjoyment or somewhere to walk, etc. So the following are some examples of some of the maps that we've created using the CS framework. So this first one's mean carbon topsoil density. And this map is produced from the mean value for carbon in topsoil per habitat. And the way it's mapped is by looking at the dominant habitat in each 1 kilometre square from land cover map, and then extrapolating across GB. So the uncoloured areas there, there's some white areas, they just show us areas where we haven't got enough data to calculate estimates. So they'd be urban or montane areas where you haven't got any soil cores, essentially. So we don't sample those. This is one that verges on the actual ecosystem service measure rather than just natural capital. This is some work that I did post as part of the integrated assessment alongside some social science researchers that have been working in Natural England to try and understand cultural services from landscapes. So we used the countryside survey data, having worked with these social scientists to understand what people like to look at in terms of landscapes. And what they like to look at is woodland, water, coast and relief. They like landscape to be up and down, so the difference between the highest and lowest part of a square is what we called relief. And so because we have the land classes underlying countryside survey, it was possible to extrapolate what we'd say for each land class, what cultural services it may be able to offer across England. And Natural England actually quite liked this because it didn't go down into the green, so everywhere has something to offer in terms of landscape quality, which is pretty much what they wanted to see and believed. Okay, so the next one is something that's newer, post the integrated assessment, and this is some work, joint work that Pete and Aidan have been doing with the BGS and the UK Soil Observatory. And this measure of carbon concentration is based both on land cover map and the BGS parent material map. So it uses grain size from BGS and land cover map as predictors of soil carbon concentration. So that map's available at UKSO with a range of other maps, I believe. And finally, this final example I'm going to show is some mapping of nectar plant richness. And this is from the 4 metre square plots in 2007, which are a particular plot type that samples areas of slightly higher quality habitats than the large plots, the X plots. And so you can see that these maps are actually for the CS squares, for bee and butterfly. And the approach used a generalised additive mixed model. Okay, so it's a particular model which uses a range of parameters from the countryside survey squares. So it uses the broad habitat, which the plots were in, the climate in the square, the size of the habitat patch that we're looking at, the length of linear features, particularly lines of trees and hedges, and also the ELS status, and that is the entry-level scheme, which is an agri-environment scheme designed to increase landscape diversity and biodiversity, its status in 2007. And so you're able to produce a map of predicted nectar plant richness. And in order to extend that out to the UK scale, we took out some of the parameters because we don't measure them in all 1 kilometre squares, but we do have broad habitat for all 1 kilometre squares from land cover map. We do have climate, and we do have habitat patch size. And so for bee and butterfly and nectar plant richness, we're able to produce a map that looks at that. Okay, so I'm now going to hand on to John, who's going to be talking about an application that was developed out of this kind of science.
Hi, okay. In this bit of the talk, I'm just going to talk about how we took some of the work that Lisa's been talking about, extended some of the modelling, and then looked at how we could make that available so that people can explore these kinds of models, can look at the strengths and weaknesses of some of the maps that we've been talking about. And the application that we developed was called Ecomaps, which you see the front screen of here. But firstly, I'll go through some of the development process. So as we've said, the principle here is that we're looking at metrics of natural capital that are developed using detailed data, and then we use some framework to extrapolate that. So we talked about the land classification as a way of taking countryside survey data and producing national maps. But what we wanted to do was to try and extend that model out to use of other data sets. So the schema for producing this type of application was that we would have detailed data, as represented here by the Countryside Survey field data map, and then we would have a range of data sets available to conduct a statistical analysis. And the first one we looked at was the general attitude model that Lisa mentioned, and that we would be able to build a model on the fly to produce this national extrapolation of the metric that you're working with, and that it wouldn't produce a single map, it would produce a range of layers at a national level that could then be assessed not only for the mean of the metric, in this case in 1 kilometre square across the country, but also the variability of that mean and the confidence of the goodness of fit of the model. And one of the advantages we thought was that you can assess how the model is performing regionally. So it's not just an all or nothing, you can look at how it performs in particular parts of the country. So as Lisa's mentioned, we looked initially at using land cover map, and we added the BGS parent material for looking initially at, in this case, this is soil microbial biodiversity as sampled by the soil cores within the 1 kilometre squares. And what you can see here is maps of the distribution of microbial biodiversity as predicted firstly by the land cover map, secondly by soil parent material, and then how the model combines these two to produce a better description of this particular measure. The key thing for us was that in addition to this, sorry, these are in black and white, but you could get the performance of the model. So what we see here is the R-square for the model using the land cover map, using the parent material, and then again looking at the combined model. And if you could see it clearly, you can see that you increase, by combining those two, you increase the confidence in certain areas of the country on the prediction you're making. We extended this to looking at a broader range of data. So in this case, this is soil characteristics of carbon concentration in soil. And what we're looking at here is building a model that will be optimal for predicting this particular metric. So as we've said, with the land classification, it's a bit of a one-size-fits-all. If you're looking at particular metrics, then what you want to do ideally is to build a model that fits the distribution of that particular metric. So by adding in land cover, climate models, deposition models such as nitrogen ammonia, and geology from parent material map, built up a model that we thought best fitted to be used for the prediction of the distribution of this particular metric. And again, we can assess how well we're doing by the statistics that are being produced from the models. We use this within the recent TELUS Southwest project that was looking at collecting a range of data in the Southwest. And what we did was to look at how these models performed in the Southwest, firstly using national data to make a prediction regionally, and then also looking at how it performed just with the regional data itself. So what we found here, not surprisingly maybe, is that when predicting for a particular region, it's always good to import data from other parts of the country where that is valid according to the types of environment that you find within that region, which is a principle which is used a lot in Countryside Survey. We can also use this principle for change metrics. So by comparing different years in Countryside Survey, we can also come up with predictions of change and then extrapolate those metrics in a similar way. But obviously, when we start predicting change, we do need to look at the confidence in the change that we're predicting and how it performs regionally. So again, we tested this in the Southwest. You'll see in there some blockiness in the model, which comes partly from the depositional data, which is at a 5 by 5 kilometre resolution. One of the issues within this modelling technique is that you can predict at any resolution you like. Though at the moment we're predicting at 1 kilometre resolution, but you can scale that up or scale that down. What you need with it is obviously the confidence measures to say, well, how far can you zoom in and still produce a valid change statistic? Lisa mentioned the UK Soil Observatory, so this is some of that data now available in the UK Soil Observatory, combined with some of the BGS survey data that was done in the southwest. And one of the things we wanted to achieve in the development of the software was to easily be able to publish data out onto websites like this to make these kinds of this kind of information more readily accessible and comparable with other types of maps. So I'm not brave enough, I'm afraid, to go for a live demonstration of this application, so I'm afraid you'll have to sit through screenshots. But basically, I'm going to go through what we did next in order to make this kind of analysis available to a wider audience so that people could explore development of these models and look at the quality of the outputs that they are producing. So the idea is you go through this kind of workflow of exploring data, setting up a new analysis, and then looking at the range of outputs that you have produced. So you have your own work area, which if you are then happy with a particular output, you can publish so other people can see that. I should say that the data that is made accessible, the data in our gridded data store, so those people who have been to the gridded data workshops, this is an application basically sitting on top of that technology. So first off, you'll see an exploration screen that allows you to look at the particular data sets that are available. The one highlighted over on the left is the land cover map. We also have chest precipitation data in the store at the moment, and the plan is to obviously greatly extend the range of data that are available to produce the model. The point data set down the bottom, the LOI point data, is the loss of ignition data set from the the countryside survey soil cores. So the idea is, having looked at particular different data sets and selecting what you might want to use, you then move on to setting up a new analysis. So in the create analysis screen, you will name your analysis, choose a model. At the moment we have this general additive model, but the idea is that other models could be added, such as kriging models, such as maybe Monte Carlo models for better estimates of uncertainty. At the moment there is only one model in there, which is the model that we've been showing the maps from. You then pick a range of data sets that you want to use to predict the metric you're looking at, and then choose your point. In this case, it's a carbon measure loss on ignition. Having done that, you set it running, and it says please wait. And depending on what the analysis is, this could take anything from 5–10 minutes. What we're thinking is, if we moved into Monte Carlo modelling, that this would take considerably more than that, and this is probably a candidate for moving out as a cloud application. So one of the things that environmental informatics is looking at is the development of cloud computing, and it may be that this would give you access into much greater computer performance that will allow you to run more complicated models. Once it's finished, you get back the results of your analysis. So in this case, you get two maps. One is the mean distribution of the mean nationally, and this is for LOI, as we said, and some measure of the variance in the model as well. You can then run through a range of statistics to check how well you're performing. So these are residuals, the distribution of the residual. We also have some measures of confidence. There is an R-squared, it's just not shown on this slide. And then this goes into your working area. So you can go back to those models at any time. You can then publish those out. So you'll see my analyses and public analyses on there. If you want to publish this, it then goes into the public analysis area, and anybody else can then see your results. So where you see all these test data sets and Lindsay, John, Aidan and all that, those are ones that other people have produced and then published out to the public area. The idea is that eventually, having assessed those models, and decided that this is something that you might want to publish, that we may then publish it out to another system, the kind of web portals that we looked at. But the other thing that we want to develop as a model is the ability to feed a national map like that back into the system as a predictor for other metrics. And this is something that Pete has talked about in terms of, and has already used in things like national mapping of pH and how that can be used as a predictor for other metrics that are being built. But clearly what you need to be able to do is to feed the confidence in the original model through so that you get this chain of uncertainties that can be calculated in the eventual product. So that application we're still working on. It's in a test form at the moment. We're hoping with more models and more data that will then become an analytical platform that people can start to look at some of these natural capital metrics and start to play with developing models and looking at how well they perform nationally or regionally. I think in summary, the first thing is that to develop good metrics, you need that detailed information, and obviously that's frequently not available nationally, so that site level measurements are really important for this. The metrics of natural capital need to be developed for a wide range of purposes, and that you need to probably look at the extrapolation models that you're going to use for those on a case-by-case basis, which we hope this enables you to do. But as Lisa has said, you always need to treat maps that you produce with a level of caution, and what we say is that what we want to do is to provide measures of variability and the strength of the model that underpins it, especially looking at regional variations in its ability to predict. Finally, the Ecomaps application, we hope, will form an easy-to-use analytical platform whereby people will have access to the kinds of data and the development of metrics and the outputs that they need in order to take this kind of work forward. Thank you.